Another Fall 19 Test 3 request item. We're going to do Fall 19 Test 3 Part 4, Question 4. We will not do number 7. That was a big question, but it's a Chapter 8 question. So it's a big question on your 4th test, I promise. But we'll do this one because it's definitely on our test. And this is all about putting a OH on one of the carbons and a Br on the other. I hope that's clear. Every product has that. O is a more electronegative atom, so I want you to put O on the more substituted carbon. We're down to this choice and this choice as the choices. And which of those do I like best? I like this one best because this reaction has a triangle intermediate. And it's the one with the backside attack creating anti-stereoselectivity. We'll be discussing that when we do our explanation. The one thing students forget most in this reaction is that water and bromine react before the alkene is even on the scene. The bromine's been added to water and stored in a chemical storage area. It's called bromine water. And before the alkene's on the scene, you get this bromine intermediate. Br with a water attached. And you get this product too, but you don't even have to draw it. That's why I'm going to draw it so small that you don't know it's there. It's not even letting me draw it. That wasn't very nice. I still think it's too big. Here we go. No. There. Good. Can't even see it, right? Bromide we don't use bromide in this mechanism. It's produced, but we don't use it. You will need a lone pair on this bromine, or else you won't make a proper triangle. These are real bonds in this triangle. This is not the mercury reaction. So to make the triangle, you need 2 more bonds. One makes a covalent bond to bromine this way. Oh, we want a bigger arrow than that. And the other, the bromine comes back to which carbon? More substituted carbon. And water leaves during this too. The first arrow actually caused that to happen. It looks like a backside attack if you look at these two. It does. It is. And what we get is and we have bromine in a corner, real bonds, and it's a plus bromine. The plus is on the bromine. It's a bromonium. And you made water, and you have lots of water. You can use the water you made or one of the waters that was there in the bromine water. Doesn't matter. And you do a backside attack. Hey, how do you know a backside attack has to be done next? I'm looking at a triangle. If you've made a triangle, your next step is a backside attack. Case closed. Which carbon? Yeah, more substituted carbon. It's a broken record. We keep saying it over and over. And you don't get the product that's circled just yet. You get its conjugate acid partner. Yes, the next step is acid base. You get your OH down here with 2 H's on it. And we need a base to take that H. We did a discussion in class. Reasons why this is the best base. There were 2 reasons why. pKb reason, and there's more water than anything in this reaction. It's an aqueous reaction. And there's your mechanism. It's all done. I don't think we did an explanation though. We circled our product. Talk about regioselectivity and stereoselectivity. Okay. Over here, do the discussion where it's important. Backside attack gives anti-stereoselectivity. There's your stereoselectivity discussion. Water attacks the C that spends more time as a C+. Why? Hyperconjugation stabilizes a tertiary cation better than a secondary in this example. So that's why water's on that carbon and not the other one. And what am I discussing when I discuss which carbon gets what? Regioselectivity. Notice I avoided using the guy's name. You can avoid using the guy's name all the time too. It's a guy's name. It means nothing to me. You can call it Markovnikov, but that's not going to, you write just Markovnikov there, I don't think you're going to like the result. I'm just going to say, what's that mean? It's a name. So I said, why water attacks that carbon? Because it's a carbon that is better able to support a plus charge, so it spends more time with a plus charge. Okay, hyperconjugation. And there's the big picture. That brings to a close this video segment. I think we answered everything. Yep. And that we're going to end and see you on the next one.